Good evening everyone, welcome back to my channel. Today we are going to do the daily Leetcode challenge of 12 January 2023. It is question number 1519, which is number of nodes in the subtree with the same level. So what does this question mean? The question is saying that you are given a tree. Okay, there is a tree given. It is connected. That is, there are two types of tree, disconnected and connected. So it is connected tree. There are no disconnected components. It is an undirected graph. Undirected means bidirectional movement is possible from edges. And it has no cycles. That there are no cycles present. Okay. So, so now what we have to do, we can see that they are saying consisting of n nodes, there are n nodes given, numbering from 0 to n minus 1. Okay, and there are exactly n minus 1 edges. That is also right. Okay, and the root of the tree is node 0. They are saying the node 0 is always the root, and each node of the tree has a label. And what is this label? It is a lowercase character given in the string labels. Okay, so now if you see this question, you may find it similar to the previous question which I discussed yesterday. Apple one, the apples in a tree, that question. So here what you have to do, they are asking you that if this is a node, in its subtree how many label are common. Okay, so let us see the tree here. So see, A is a tree and its subtrees are these one and these one. Okay, so in its subtree how many A's are present? Only here. So the count of A will become 2. Okay, now if when we move to this B, how many B's are present in its subtree? That is this subtree and this subtree. There is only one B, so it will return 1. So comma 1. Similarly for others, you will get 2 1 1 1. That is the way. You might find it interesting that there are 2D available, but why there is no 2 here? Because these are not part of subtree of each other. Okay, the labels will be counted only when it is a part of their subtree. So that is what you have to do. So it's similar to previous question in such a way that in earlier question you was finding the number of children, yes or no, which has apples. So now you will check whether the children of the node has a same label or not. That is what you have to do. Okay, you just have to check whether the node children have the similar label or not. If no, then you will move on. Okay, then you will simply return 1. So in this question, if you see in this example, it is having B. Okay, so now what will happen? This will say how many node you have. It will say I have 1 B and it doesn't have children. Okay, so when we move to here, it will ask his children. It will also ask his children. It will say I don't have any children, but I have B. It will pass B. It will say I also have B. So 1 plus 1, 2 will be passed. Okay, and from here 1 is coming. So total how much? Total 4 B's are there. Yes or no? So that is what is happening here. Okay, so that's why the output is 4211. Why? Because for the first 0 node, this is for 0 node, it is 4. When you move here to the B node, what it is? It has 1 and 1. Total 2 value. So total 2B. And when you move on to the last node here, it only has 1B. So it is returning 1. Same goes for this 3. That's why the answer is 4211. You have to check for the same label in the subtree. That is what you have to do. Okay. So I hope you have got an idea how to approach the question. So I request you all to please take a minute and try to do it on your own. Then come back to the video. I hope you have tried the question on your own. Now see how we can do it. So in general, in the graph questions or tree question, you have to traverse the tree or traverse the graph. And for graph traversal, there are two ways possible. One is breadth first search, another is depth first search, BFS and DFS. So what do you think, which approach should be applicable here? The depth first search will work here. Yes or no? In the previous question of that Apple one, we also see that depth first search was used because we have to reach to the depth, because we have to check every node that whether it has same level or not. So for the brute force, you can see that you will check whether its subtree have A or not, whether its subtree have A or not. So you will be checking for every node. So that will be a very high time complexity. Yes or no? So what can be the optimized approach? So for the optimized approach, you will apply the DFS and you will check whether, you will ask him whether your children have A or not. It will say no, my children doesn't have A, but I have A, so it will return 1. Same goes for here. That is how it is working. So let's just move on to the coding part so you can understand it better. So what's the first step you can think of in the coding part? So the first step in the coding part will be, let me just zoom it for you first, then we can start coding part. Now see, as I told you earlier, whenever you are given these type of questions, you have to create a adjacency list. Adjacency list is a relation of 0 with this 1 and 2. Oh, let me just write it for here. The relation of 0 with 1 and 2 is its adjacency list. This is how adjacency list is made. And the relation of 1 with 0, 4 and 5. This is a adjacency list. The relation of 4 is only with 1. The relation of 5 is also only with 1. So this is how a adjacency list is created. 2 has relation with 0, 3 and 6. So this is how an adjacency list is created. So for questions like this and for applying depth first search DFS, you have to create an adjacency list so you can traverse. An adjacency list give you a relation between the vertices. So you do not repeat the vertices again and again. Okay. So now let's code this. When we come to coding, let's just create a adjacency list of n size. Now when you have created the adjacency list of n size, you also need a vector to return, because the answer is in vector now. You have to return a vector array which is storing the count of every same label of the subtree. Yes or no? Same label of a subtree you have to return in a vector form. So let us create a vector answer, because we have to return an integer vector array. Yes or no? And now what we have to do, what I told you, we will have to push what? We have to push all the vertices inside our adjacency list. How can we do that? I told you, yes or no? Adjacency list, we write x0 dot push back x1. So it is saying simply that relation of 0 with 1 and 1 with 0. Yes or no? Because it is an undirected graph. That's why the bidirectional relation is possible. Okay. So I will show you it again in the figure. Let me just write it first. So this is how an adjacency list is created. Yes or no? So the relation of 0 with 1, let me change the graph. So relation of 0 with 1 and relation of 1 with 0 is shown in the adjacency list by doing this. Yes or no? 0 with 1 and 1 with 0. And what is this 0 and 1? It is denoting just the first node. So first vertices, 0 and 1, then 0 and 2. It is forming a bidirectional edge between the two vertices. Okay. Now, what I told you, we have to apply DFS. So how can you apply DFS? First, let us write what we have to return. We have to return the answer vector. So let us just write return answer. Okay. So what will be the size of this answer array? So we know that every label has some value. So its size will be n and it will be having one value at least. Yes or no? One label will be there, minimum. So we will create the vector of size n with value 1. Okay. Now for the DFS call, what we have to pass this label so we can get the what the label is actually. Then we will have to pass the current node, that is 0 startingly. And what is the parent of 0? It is -1. Okay. And what you also have to pass, you have to pass adjacency list and also pass the vector answer, so you can get the answer. Okay. So now let's create this DFS function. What will be the data type of this DFS function? Can you tell me? Yes, the data type of the DFS function will also be a vector, because we are dealing with vector and we have to return a vector array of the count of labels of the subtree. Okay. So what you have to pass, you are passing this same string labels and you have to pass it by reference so it does not create a copy of it. And now you also have to pass what? It is current node. Current node you can also write as int node. And what is the parent? You write it as parent. And then you also have to pass the adjacency list. You pass the adjacency list by reference as well, so it does not create higher time complexity or higher space complexity by creating several copies of it. And if you are passing it by reference, the reference is taken from here and it is adjusted as an overall function. Whatever happens here in this above function will also happen to its parent function. That is why pass by reference is so much important to reduce time complexity and space complexity. Okay, now you also have to pass this vector answer, and you also have to pass it by reference so it does not create its copies. Remember guys, by reference is so much important. These small things matter. So now what's the first step you will do? You will create a frequency array so you can store the frequency returned by these points. So the frequency returned by these points means that what is happening here, what exactly is happening, this 4 will return that I don't have any a, I only have d, one d will be returned. This b will say that okay, then it is done. For 5c will say I only have one c, I don't have a. Okay, then what is 1b having? It is having 1b, 1d and 1c. Okay, so it will say A, I don't have A, but I have B, D, and C. So that is being returned. Yes or no? Same goes here. It is saying my children doesn't have A, but I have A. So you can have my A, you will have my E, and you will have my D as well. So how can you store these values? You have to create a frequency array, so which can count the frequency after every DFS call, that what is returning from this node, from this node. Yes or no? So for that you have to create a frequency array. You can create a frequency array of size how much? 26, because there are 26 alphabets, and as it is in lowercase, you don't have to consider the uppercase letters. Okay, and let us make the current frequency as 0. So this is our vector. So what exactly you have to do in DFS? As I told you, you have to iterate through the adjacency list. Okay, so when you iterate through the adjacency list, you will go through every node, and what you will check? You will check whether it is equal to its parent or not. So what I mean is whether this vertex is equal to its parent. If it is the case, we will not iterate through it. That is why adjacency list is created. Yes or no? So what exactly happens in a DFS? You should also create a temporary vector temp which will store the value. Okay, what values? The value of DFS count, which it is returned from the 4, from 1, from 5 individually. So what it is returning? You will pass the labels function, string labels. You will pass the, what will be the current node? The current node will become b. For 0, if it was at 0, it will come to 1. Now the parent will become what? The parent will become the current node, and adjacency list remains same, and the vector answer remains same. So when you are done with the DFS, this temporary value will have the count returned from the variable 1 or 4, what it is returning to the parent function. Yes or no? So what you have to do, you will iterate through it and you will store the value in the count frequency. How can you do that? I less than 26, I plus plus, and you are storing the count I. You are storing the frequency returned by this function, the temporary function, into it. And when it is done, what you have to do? So what is this? It is saying that one is saying that my children doesn't have your label, so it is returning 1. But in this case, when it is saying that my children doesn't have 1, but I have 1, so you have to get the frequency of that label as well. Now this is not done here, it is just telling you the frequency of the children. So for the current frequency, what you can do, what you have to do, you have to get the frequency of it. Yes or no? So how can you do that? Yes, exactly right. You will get the ASCII value of that character. So how can you get the ASCII value of that character? Let us create a variable int ch, and you will write what? Labels node minus small a. This will give you the ASCII value of that character, and you will update it in the frequency array, and you will increase the value of that character in the frequency array. And when the value of that character is increased in the frequency array, what we will do? We will update it in our answer array. That is, answer node will become is equal to count ch, and we will return the count, so the DFS can continue and the answer node will get updated every time. So we are getting the final answer as 2111, as I explained you in the examples part. So let's just run this and see whether it is working or not. Silly mistake, we have written, it should be written. Now it should work. Let's see. Yeah, it is working. Every case is passed. Let us just submit it and see whether it is getting accepted or not. So yes, it is getting accepted. So the time complexity of this question will be on and space complexity will also be ON, that is linear time and space complexity. So now let me just brief you the question again and how I actually approached to the solution. So the question was very simple. You was given a tree and you have to return the label count from the subtree. So one thing was for sure that we have to traverse the tree. For traversal we have two options, BFS and DFS. And I have to reach the last node or the last leaf node from the root node. I should use DFS because it will give me the depth results. So that is why it was preferred. So when we applied the DFS, we asked the parent whether its children have the same level, and the children were answering that I have the same level or not, and they are returning the value. And when this whole process was done here, the current label will say that whether I have that value of label or not, and it is returning to the parent value. So that is how DFS was used here, and that is how we approach to the conclusion that how to solve it. The frequency array part was pretty much important, so make sure you understand it. If you have any doubt, do let me know in the comment section. And please like, share and subscribe the video for more Leetcode daily challenges. And do comment other questions you want me to solve. Thank you for watching. Bye bye.